All right, so in this video, we're going to take a look at just a quick review of scientific notation. Or sometimes it's referred to as exponential notation because we do use exponents. And it's often abbreviated as SI, psi naught for scientific notation. So when it comes to scientific notation, we use this a lot in chemistry, probably physics as well. And we use scientific notation to represent typically two types of numbers. So we use it to represent either really big numbers, really large numbers, or on the other end of the spectrum, really small numbers as well. And we do encounter these two extremes of numbers in chemistry quite frequently. So for example, when we start delving into matter a little bit more, in a little bit more detail, and we look at the things that make up everything around us, the things that make up matter, we'll get down to the level of atoms and even subatomic particles. And their dimensions tend to be really, really, really tiny in terms of their sizes, and their masses also tend to be really small as well. So if we have these really tiny things that we really can't see with our naked eyes, we actually need a really large number of them to come together to actually make up the stuff that we do see. All right, so that's sort of where we encounter these numbers, these really small numbers, really big numbers, and why scientific notation is going to be so important, how to interpret it, how to represent numbers in scientific notation, how we use our calculator, how we do calculations also. So as an example, let's say that we measured the size of an atom. Specifically here, we're looking at, maybe the diameter of an atom. And I'm just going to make up some numbers. Let's say that it is 0.00000000095 meters, right? So it's an incredibly small number. If you can imagine an atom being a sort of spherical, and then we had a sophisticated enough measuring device to measure the diameter of an atom, that distance. We find that, let's say, for instance, that it's this value. That's obviously very small, and it takes a decent amount of time to write that entire thing out. So when we go from this regular decimal notation, and we want to convert it to scientific notation, what we want to do now is we want to find our decimal point. Okay, so in this case, we have an explicit decimal point right here, and we want to move it. We want to move that decimal point either to the left or to the right so that we end up with a number between 1 and 10. Okay, so in this case, we want to move our decimal point to the right. We're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So if we move it 10 places to the right, so we're going to move decimal point 10 places to the right, we end up with a number 9.5, right? And that's a number between 1 and 10. And then we're going to take that number, we're going to multiply it by 10 raised to a certain power. And that power is how many places I had to move the decimal point. So I moved it 10 places. Let me double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. And I moved the 10 places to the right. Okay, so not only is it the exponent here going to be 10, or the power is going to be 10, it's going to be a negative value. So this number is the same, that 0.00000000095 is the same as 9.5 times 10 to the negative 10. And don't forget your unit here now. It's meters. So any number written in scientific notation is going to look very similar to this. Okay, so the basic layout then is going to be the same. We're going to have a number here, regular number written in the front, and this is called the coefficient. Okay, and the coefficient has to be a number. This is the format for it, a number between 1 and 10. And then the next part of it is 10 raised to a certain power. Okay, and that's the exponent part of it. And all your numbers in scientific notation are going to look this same way. So the power then, as we saw in the example above, this can be negative or positive value. And right away, we can now sort of come up with a general rule and a general way to sort of develop some intuition about sizes of things written in scientific notation. So if the sign of the exponent is negative, this means that the number is small. Okay, so in this case, 9.5 times 10 to the negative 10, that tells me right away, once I look at that exponent, that power of 10, I know right away that is going to be an incredibly small number. And by the same token, the opposite would be true. So if I end up with an exponent scientific notation value, and if the sign of the exponent is positive, that then would tell me that the number is large. Okay, so as an example for that one, if I had a number like this, and we are going to see this number, by the way, a lot in our class. So 603, let's change that to 602. Thousand, 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 thousand. So let's see. We have 3, 6, 9, 12, 15, 18, 21 zeros. So this obviously is a huge number. Okay, this is a large number, and it took me, whatever, 10 seconds or so, 5 seconds to write it out. If I want to convert this now to scientific notation, okay, just like we did before, the first thing that we do is we found the decimal point, right? Which we found over here. Well, in this case, there isn't an explicit decimal point, but one is implied to be at the end of the number. Okay, so our implied decimal is at the very end. If you don't see one, and we're going to do the same thing. We're going to move that decimal point now either to the left or to the right to get a number between 1 and 10. So in this case, I'm going to move my decimal point to the left. So how many places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I end up with that decimal point right here. So that becomes 6.02. That now is my coefficient. Okay, I'm going to multiply that by 10, raised to a certain power now. And that exponent is how many places I move the decimal point, which, if you recall, is 23. Okay, so that's my number in scientific notation. And it makes sense now because this here is a positive exponent. Okay, and just by the trend we mentioned above, makes sense because this then would indicate that it's a very large number. All right, so the sign of the exponent tells you the magnitude of the value, and the first part of it, the coefficient, gives you the actual number involved. And by the way, just so that you know, we're going to see this number, like I said, over and over and over again. That number has a special name. It's called Avogadro's number. It's named after a scientist called Amadeo Avogadro. He actually has several more names, but 6 or 7 names, but that's his first and last name. He has lots of middle names. So Avogadro's number, which has an abbreviation, it's called NA. And you'll see that in your textbook. If you look in the inside cover, the first couple of pages, that usually is written, and it goes to several more decimal places. But for our purpose here today, this is what we mean. So that's how we go back and forth, how we go from a decimal number to a number written in scientific notation. Couple things to note now about your number in scientific notation. And we did talk about, sig figs and all that stuff, or we will be doing in some of the other videos. So when we write a number in scientific notation, the number of sig figs, right, is indicated by the coefficient. Okay, so for example, in the two ones we did before, we had 9.5 times 10 to the whatever, negative 10 meters. To determine the number of sig figs that we have in this number, this measurement, we look at the coefficient. Okay, so here we obviously have 2 sig figs. And the number we had before, the immediately preceding, we had 6.02 times 10 to the 23. Well, this is what we look at for the number of sig figs. This then would have 3 sig figs. Okay, so that's one thing to note when it comes to identifying the sig figs in a number written in scientific notation. All you do is you just focus in on that coefficient and you apply the rules for identifying sig figs to that particular part of the number. So one last thing when it comes to scientific notation, you want to make sure that you are able to enter your numbers in scientific notation. So enter them into your calculator. Properly. Okay, so there are many ways. There's actually at least 2 different ways by which you can enter numbers in scientific notation, depending on the type of calculator that you have. So you want to make sure that you practice this. And if you're unsure, obviously you want to check with me. But it's really critical that you're able to do this because it will make your life a lot easier when it comes to performing calculations. Not just questions like these where it has you practice with the with the scientific notation, but when it comes to actually doing problems like using chemical equations and stoichiometry, for instance, you will need to use scientific notation in those calculations. So make sure that you're able to do this. So this depends generally on your calculator, but they all have essentially one way that's common to both of them by which you can enter these numbers in scientific notation. On obviously then check with me if you're unsure. Okay, it's very important that you know how to do this.